Hello and welcome back. So far we have understood the gradient descent, how the algorithm works with graphically intuitive example. Let us try to look at the issues with gradient descent in this particular video. We have started learning or understanding gradient descent after looking at problems in the normal equation. The problems in normal equation are two. One, huge volume of data it cannot handle. The second, there is a dummy variable trap. The gradient descent definitely solved the dummy variable trap. But huge volume of data issue is still there in gradient descent. If you look at this particular code snippet, which is trying to do gradient descent on a small data set. So if you look at x and y, the input values are present in x and the output values are present in y. We are doing 70 iterations. In each iteration, if you look at this particular highlighted block, we are calculating gradients or the slopes. The slope of the tangent at this theta. How are we doing it? X transpose, then X transpose theta minus Y, right? So X is what? The whole data. If you have 1 record, 100 records or 1 billion records, it doesn't matter. While calculating gradient, we are using the whole data here. And then calculating next theta is equal to current theta minus eta into gradient. So this gradient is calculated on whole data set. And then we are finding out the next theta. How many times we are doing it? 70 times. 70 iterations or 70 epochs. We call them as epochs in machine learning. So 70 iterations we are doing. So if you have 1 billion records, you will be doing 70 billion math calculations. And one more thing is, your computer, your local machine cannot handle 1 billion records at once to do this matrix manipulation. The vectorized implementation of calculating the theta transpose x and subtracting it from y, subtracting y from the theta transpose x, the predicted value, and then multiplying it with x and dividing with m. This whole calculation cannot be accommodated in small memory computers like maybe 32 GB, 64 GB also not sufficient, right? So gradient descent algorithm clearly shows that it is using the whole data set to calculate each theta, or every iteration it is using whole data set. For each step it is making in that parabolic curve to move right towards the global minima, for each step it is using the whole data set. On a huge volume of data, gradient descent algorithm cannot work because it is doing this matrix manipulation in memory. To solve this problem, we have stochastic gradient descent. Before we understand stochastic gradient descent, I would like to highlight 2 points. One, it is using 70 iterations. If you have 1 billion records, it's going to do 70 billion calculations. And then 2, right here, by the time it reached the 60th epoch or 60th iteration, it actually found out the best thetas or the error, minimal error. In this particular dataset, we have got 25 records. And if you look at 60, 25 into 60 is 1500. 1500 calculations it did to find out the best theta or the minimal errored theta. Okay, so we will see how stochastic gradient descent works and how can it solve the memory issue and how can it actually find out the best thetas in less number of math calculations. Let's meet in a separate video to understand stochastic gradient descent. Thank you.